So we'll talk about the difference contrast. So here we compare each level to the average of the previous levels. Okay. So in my data set, that will mean comparing, let's say, comparing diary to the average. That's diary diet to the effect of diary diet to the effects to the average effect of both exercise and vegan diet. Okay, so and then the last one is deviation contrast. So you're comparing each level to the overall mean of all the levels. Okay, so all these contrast SPSS can do for you. But then what if you have a specific combination that is not in SPSS? What are you going to do? In that case, we use the L matrix SPSS syntax. So this is the syntax that we're going to use. Now this is my intervention group column. Okay, so it's the same as the name, as my column, the column name here is the same thing. Okay, so now I want to explain what does this 1, 0 and -1 mean. So basically the first number is the first level of your independent variable. The second number is the second level of the independent variable. And then the third number is the third level of the independent variable. Okay. So now when you want to compare, for example, now let's say that you want to compare, let's say you have your independent variable has 5 levels, drug A, B, C, and D. Okay, and then you want to compare the average effect of drug A and B with the average effect of drug C, D, and E combined. Okay, so how will you assign the weights? So here we make sure that everything sums up to 0. So for example, here 1 plus 0 and -1 is 0. So because we want to compare the average effect of drug A and B to the average effect of drug C, D, and E, we want drug A and B, their weighting, this total weighting should be 1. And how can I make it to be 1? I'll divide 1 by 2. So that will be, I'll give this one half, and then I'll give this one also half. Okay, so half plus half is what? 1. Now the comparison group, I want to make the total sum for the comparison group to be -1. So I'm comparing drug A and B to drug C, D, and E. And for me to do that, how do I make the weighting for drug C, D, and E to be equal to -1? Because there are only 3 drugs, I'll divide 1 -1 by 3. And that's how I arrive at -1/3 for each of them. So my SPSS syntax or my SPSS code to run that comparison will be as shown on the screen. Okay, so half here represents my the first level of my variable. This half here represents the second level. This represents the third level of the variable. This represents the fourth level, and this represents the fifth level. So now in my own research, in the data that we are analyzing, here, what does 101 mean? So 1 refers to the first level of my variable. So the first level of my variable is what? Exercise. So 1 refers to exercise. Then 2, that's this 0 here, refers to the second level of my variable. That is what? Vegan diet. So that means because I'm not interested in vegan diet, I'm only comparing exercise with diary diet. So that's why I'm assigning the weight for vegan diet to be what? 0. And then the third variable here, I assigned it a weight of 1. Sorry, a weight of -1. Okay, so that is my diet. So I'm comparing exercise with diary diet, ignoring vegan diet. Okay, so having said so, we'll now go straight to the practicals. Okay, so for us to run our repeated measure ANOVA, we go to analyze, general linear model, repeated measures. Okay, so within subject factor is always time, so just type in the time. Okay, then number of levels. How many times did I measure my subjects? I measured them 3 times at month 1, 6, and 12. So I'll enter 3 here, add. Then, so now I need to define the components of my time. So the first one is weight. I'll add it. Then the second one is what? Mental well-being score. Okay, mental well-being score. I'll add it. Then click on define. So for the weights measured at month 1, 6, and 12, I will just click this arrow and drag, and then that will enter into this place. While for the mental well-being score for month 1, 6, I will highlight all of them and then click on the arrow, it will enter here. Now for the intervention group again, I'll click on it and then click on this arrow, it will enter here. So between subjects it always refers to the groups, while within refers to the times of measurements. Okay. So for the model, I'll just leave it at full factorial. For the contrast, I've explained the contrast before. I just want simple contrast. Okay. Then I'll change my reference category to be to the first. So that means I want exercise to be my baseline. That's to be the reference group. Okay. I'll click on change. Sorry. Okay. This is for the time. So that means time 1, month 1 is my baseline. Then I'll click on the intervention group again. Select it as simple contrast. Then click this as first, so that exercise will be my reference category. Then click on change, click on continue. Then for the plots, now I'm going to do 2 plots here. I don't know the one that will look better. Okay, so I'm going to just move in the intervention group to the horizontal axis and the time to separate lines, and then add. This time around I'll move time to horizontal axis, move the group to separate lines, and add. Okay, so I don't know the one that will look nicer, so I will, when I see it, I can interpret, can select the one that looks better. And then click on continue. Now for the post hoc test, click on the intervention group, move it in using the arrow. Post hoc test, I just select Turkey test. Okay, and then for the options, highlight everything here, click on the arrow to move it into that's the estimated marginal means. Check compare main effects, select Bonferroni here, Bonferroni confidence interval adjustment, click on descriptives, estimate of effect size, that's the partial eta square, observed power, and homogeneity test. Okay, then click on OK, then click on OK. All right, so this is This is the output, the airspace's output of my test. All right, so we will just go straight to interpret. So basically, within subjects here is telling us what the variables are. Okay, you have the weight and mental. That's the within subjects telling us the variables. So you have time 1, time 2, time 3. Okay. Then, like I said, between is all about the groups. Between subject factors, the groups, the exercise, vegan diet, and diary diet. Here, you have your descriptive statistics. So this is telling us the mean weight in month 1 for the exercise group is 54.08. For vegan diet, 2.05, and for diary diet is 51.662. Okay, just like that. So we have month 1, 6, and month 12 for the weight and the mental well-being score for month 1, 6, and 12. Now, like I said, if you watch the previous video, the box test of equality of covariance, the assumption in ANOVA is that it should not be significant, but here it is significant. Okay, so what we said in the last video, we said that the multivariable test is a robust test. Even though the box test is not significant, if you have a fairly large number samples that are fairly equally distributed in the groups, then it is not going to affect it. Okay, it's not going to affect it. Okay, so even though our box test is significant, it doesn't affect the multi-variable tests. Okay. All right, so that's the box test. Okay, so here, so we said in the last video that the multivariate tests are very robust. Okay, so far as you have a large number of sample size and nearly equal number of participants in all the groups, such that the ratio of the largest to the smallest number in each of the groups is less than 1.5, then you are good to go. Okay, so when the larger group is the larger the group, then the less sensitive this box M test becomes. All right, so with that, we continue our interpretation. We go to the next slide. So like I said, the multivariate test is a robust test. Okay, so it is not sensitive to sphericity, which is one of the assumptions that univariate test that we have to obey in univariate test. Okay, so we can safely, even if our assumption for specificity is not met, we can still utilize the multivariate test. And our preference here, from our last video, we said that we'll interpret, will likely, most authors favor interpreting the Weeks lambda test. Okay, so the Weeks lambda test here is you can see that our Weeks lambda test here is significant. Okay, for the between subjects, and also significant for the within subjects. And then you will also see that the interaction of time and intervention, the p-value is significant, 0.000. Okay, so if the interaction between time and the intervention is significant, then you don't need to focus on the effects, the between subjects effect and the within sort of subject effects. You have to investigate this interaction further. Okay. So in our model, the interaction are significant. So we need to find where this interaction is actually. Okay. So, but for the sake of teaching, we just continue to we just do everything the way it's supposed to be done. Okay. All right. So now, so here the between subjects effects is significant. So like we said in the what does it mean? What does between subjects mean? If we go back to our research questions, so we said between subject effects is answered. Is there a significant change in the effects of what? In the effect on the effects of the independent variable on the dependent variable regardless of time. So between subjects doesn't consider time. Okay, so regardless of time, regardless of the impact of time, you will see that the intervention uh, had significant. There are differences in the effects of the interventions. They have significant differences in the effects of the interventions. Okay, so this is the intervention group here. It is significant regardless of the impact of time. Okay, now within subjects here, the with lambda is also so significant. So it's telling us that even when you consider the impact of time again, is there a significant change in the effects of the independent variable on the dependent variable across different time points? So yes, so here our model is telling us that yes, there is a significant difference in change in the effects from time point 1 to time point 2 to time point 3. The effects are significant. Okay, so that is that. So like I said, Murchie's test of sphericity. So this is one of the assumptions here. Is so basically um, one of the assumptions of repeated measure and over is that this Murchie's test of Murchie's test of sphericity is not significant. Okay, so that means that um, the covariance matrices of both groups of variables are proportional to each other. Okay, so now we said before that if we are using the multivariate tests, we don't need to worry much about the sphericity because it is robust. Okay, it is robust. So here our Murchie's test is significant here. So, but we don't need to still worry much about that. Okay. So where sphericity becomes important is in the univariate test, assuming that we are focusing on the univariate test. So what does it mean when you say univariate test and multivariate test? What do you actually mean? Now, multivariate tests here, we are talking about the effects of each of the independent variables, okay, when considering the overall model, okay. But in univariate analysis, in univariate tests, you are only looking at the contribution of each of the variables alone themselves, okay, without considering the effects of the impact of other independent variables. For example, now this is we are looking at the impact of weight. Sorry, the impact of the impact of time alone on weight without considering the other variables. That is significant. So if we are reporting this in a univariate model, then we must make sure we utilize the assumptions of sphericity. So like in our model, our sphericity was not significant, and we said that if the sphericity is not significant, what we use the greenhouse gaser test. Okay, and once it is below 0.75, we can safely use the greenhouse gaser test. Okay, but we are not. So in this tutorial, what I'm reporting is the multivariate test. Okay, so but if we use the greenhouse gaser test here, the greenhouse gaser test is also telling us that it is significant. Okay, that the impact of time on the weights is significant here. Impact of time on the mental well-being score is also significant. Okay, that's the effect. And it also the greenhouse gaser test is also telling us that uh, the impact of time, the impact of interaction of time and intervention, as the interaction between the two is also, it has a significant effect on the weight and also a significant effect on the mental well-being score. You see that? So whenever you are using the univariate, remember to obey the rules of sphericity. But if you are not using it, it's a matter of choice. If you are not interpreting it, then you just focus on the univariate analysis. So you focus on the multivariate analysis so that you not worry about that. Okay. So now we'll come back to the contrast. So let's just go straight. So remember we said that when your interactions is significant, so you can see time and time times intervention. So the interaction between time and intervention is significant. Okay, is significant. Sorry, is significant. Yeah. So now you ignore, you don't focus on the between and within. So we want to know where is this significance? Where exactly does this significance lie? Where exactly? Because we know that time and intervention, the interaction of both is significant. Now look, this is even more serious. So we want to know where exactly is this significance? Where exactly is this interaction? Okay, and that is why we now need to go to the code of the SPSS syntax in order for us to find out, because SPSS doesn't give us that value. Okay, so for us to get the code for the SPSS, we'll go back again to do the analysis. Go to analyze again, general linear model, repeated measures. Now we've already done all this before. Okay, can define. So we've already done everything. Just click on paste. Once you click on paste, the code box will appear. Okay, so now the code box has appeared. So now we want to do what we want to include. If you're doing this for the first time, you want to include a line, because this, you have to include a line here, because can you see that here it says EM means of tables. Okay, that's EM means tables, intervention group times time. That's the interaction. Okay, so you need to add this, compare this line again, this line of code. Let's copy it and say I want you to compare. Okay, compare and adjust the Bonferroni confidence intervals, okay, for the group and time. Now, then you will now say what exactly are we comparing. We want to compare the time, but you can remember we said that the interaction is significant. So here in S spaces, if you want to write the name of the column, you put it in a bracket. Okay. So what we added, this line here, is what you're supposed to add. Remember, we're looking at the interaction. Where exactly is this interaction? We don't know. Okay, so I'm going to copy this again. And then I'm going to paste this again. And then here I will change this to the second group, intervention underscore group. Okay. And then I will, so once I've done that, this is the line of code that you're supposed to add. So these two lines here. So I'm comparing this, the interaction. As the table is interaction table, then you compare the time, compare it across time. The same thing again, interaction table, compare it by the group. And then once you're done, just click on this arrow key to print the results. Okay, so I'll just clear everything and then just do my code, run my code again. Okay. Okay, so so if we just scroll down to look at the output of the code that we wrote, just look for it. So there's a profile plot, multivariate tests. I'm just looking for custom tests here. Okay, so you see this custom hypothesis test here. We're comparing, we compared level 2 versus level 1. So you will look at the significant results. So you see that level 2 versus level 1. So this is very significant. So that means that there is a significant difference in the effects of exercise and vegan diets. Then if you also look at this is level 3 versus level 1, the significant value is 0.000. So that also tells us that there is a significant difference. As level 3 and 1, there's a significant difference in the effect of diary and exercise. Okay, so that's the custom hypothesis. All right, so now we need to know we need to know where exactly are these effects. That's where you go for you look at the pairwise comparisons. So the pairwise comparisons here, we are seeing that, remember, this is mean difference I minus j, so this is I intervention as exercise minus vegan diet. Okay, so you can see here that there is a significant difference in weight between those that exercise and those that took vegan diet, and also between those that exercise and those that took dairy diet. So it is very significant. Okay. So that is for the pairwise comparison. Also look at the mental health score again. Between exercise and vegan diet is significant. Between exercise and dairy diet is significant. So basically, there are significant differences between the three intervention. There are significant differences in mental health score between those that exercised and those that had vegan diet, and between those that had vegan diet and those that had dairy diet. Can you see that? And also between those that had exercise and those that had dairy diet. So that's what this pairwise comparison is showing us. Okay. And the overall model is significant. So we've already done this before. This is the Wilson-Lambert test. Now, looking at the impact of time. Okay, looking at the impact of time, we'll just go straight to the pairwise comparisons. So, when it comes to weight, in month 1 and month 2, there was a significant difference in weight. Between month 1 and month 3, there was a significant difference in weight. Looking at the mental health score too, you will see that between month 1 and month 2, there was a significant difference, and between month 1 and month 3, there was a significant difference in mental health score. So basically, these are significant. And then looking at the interaction between the intervention and the time, which is what we are looking at. Okay, so we can see that these are the mean weights for the mean weight for those that exercised here was the highest. That's 105.77, while those that took diet was 101. That's in the mean weight in month 1. The mean weight in month 3 for those that took exercise was the highest here, 105.77, while the mean weight for the vegan diet was highest in month 3, 101.157, and these are the confidence intervals. Now this is the pairwise comparison for the interactions. So you will still see that they are all significant, apart from the interaction in dairy diets between time 1 and between time 2 and time 3. So that's this one here. It was not significant that means the weight difference was not significant for those that took dairy diets between 12 months, which is time 3, and 6 months, which is time 2. And also the mental health well-being score. The difference in mental well-being score between those that took dairy diet in month 1 and the 6th month, that's 2. there was no difference. So the others are significantly different. Okay. And looking at our Wix and Lambda, the overall model for the interaction is significant. We have said that before. Okay. So basically, this is still our post hoc test, Turkey HSD test. So you can see all the starred models, all the ones we starred, they are all significant. The interaction between weight, the interaction between weight and intervention. So the interaction between the independent variables, the interaction between the independent variables and time, they are all significant. So here, this is saying that there's a significant difference in weight between those that took those that engage in exercise and those that had vegan diet. So I minus j, so that means I minus j is equal to 7.1. So that means those that engage in exercise were on the average 7.1 more. They weighed on the average 7.18 or 19 kg more than those that took vegan diet, and this is statistically significant. So the same way to interpret the others. Okay, so now these are the two charts, that's the two diagrams that I drew. Don't know the one that looks better. Okay, so I think this one looks easier for me to interpret. This one here. So blue is those that had exercise. So can you see that those that had exercise had higher weight on overall? Generally, they had a higher weight, and it was significant compared to those that did not exercise. Those those on dairy diets, their weight decreased over same period, over the 12 months period. Their weight decreased. So there was a very significant difference in the weight. Then looking at the mental health score, the two charts, I think this one looks easier for me. Those that exercised in this test had poorer mental health. This is month 1, month 6, and month 12. The mental health decreased. Those on vegan diets, on the average, their mental health decreased between month 1 and month 2, and then increased in month 3. Why those on dairy diets, they all did poorly. Okay, so I'll end this video by showing how you can report your findings. How to report your findings. So this is just a sample of how you can report your findings. Okay, thank you so much, and God bless you. See you in the next video.